Bismillahirrahmanirrahim. We will discuss about the linear programming. As we know that for the decision making, the linear programming is one of the tool that is important for solving different problems. Now you can see that in linear programming, um, a desired benefit, like we discussed earlier in the class, that such as profit or any other thing can be expressed as a mathematical function. So the solution is a set of value for the independent variables, that is decision variables, that's to maximize the benefit or to minimize the cost. So these are the two major objectives that we can do from this linear programming techniques. And the most important things, we have the constraints of that problem also. So the four major steps. First, we have to state the problem. The second one, what are the decision variables? And the third one is uh, objective function. And the fourth is constraint. So we have a problem here um, that we will see. So you have the problem that considered a factory producing two products, product X and product Y. The problem is this: if you can realize $10 profit per unit of product X and $14 per unit of product Y, what is the production level of X units of product X and Y unit of product Y that maximize the profit P of each day? Your production and therefore your profit is subjected to resource limitation or constraint. Assume in this example that you employ 5 workers, 3 machinists, and 2 assemblers, and that each works only 40 hours a week. So this is the problem you have, and the basic profit on X product is $10 per unit, and on product Y, that is $14 per unit. So here's the case that the production level is represented by a small x of x units and small y of y units. And we have to find this. So one more constraint that is given is that you can employ only 5 workers, 3 machinists, and 2 assemblers that each work 40 hours a week. So we can say that there is 5 workers, so each have to work 8 hours. Now product X required 3 hours of machining and 1 hour of assembly per unit, and product Y requires 2 hours of machining and 2 hours of assembly per unit. So this is also the condition. Now the basic problem, as we discussed in the previous slide, that we have to state the problem, and the problem is how many of the product X and product Y to produce to maximize the profit. So we have to check that how many products we can produce to maximize the profit. So the decision variables, we have small x, number of product X to produce per day, and Y, number of product Y to produce per day. So the objective function we have is 10x plus 4y. Now here you can see that um, objective function we can derive from the upper given equation. That is, first we have the product X, that is $10. So we can write 10x. X is basically the production level of X units. The second one is Y. So Y is $14 per unit. So we can write our mathematical equation, that is P is equal to 10x plus 14y. That is our objective function. Now there is also constraints given, and that is also a mathematical equation, that is 3x plus 2y less than equal to 120. So we can also consider it is equals to, the second constraint is x plus 2y, that is equal to 80. Now you can see that This constraint is basically, you can see that 120 and 80. So the total machining time is 3 hours and 40 hours per worker. So 3 hours of machining, we require three workers for this. So total is 120, and for assembling purpose, we require two workers. So 40 into 2 is 80. So this is the basic equation. So in this section or linear programming section, the most important thing is to understand the problem statement. If we understand the problem statement well, so there will be no much difficulty in solving the problem. So I solved it here. Again, I write this um for the convenience to clarify the more steps. Again, the decision variables here we have that we discussed. Objective function is also given, that is of profit. The constraint is also given. Now, as we can see that this equation we have P is equal to 10x plus 14y. So first we will check this by considering this P is equal to 0. Now, from the graph we see, you can draw the graph by hand. I use a software to draw the graph so you can see it clearly. Now, this point is basically the P is equal to 0. Now at this point, when P is equal to 0, we have X and Y is also 0. So by increasing this, we will take the value 350. And remember that these values 350, 620, and 700 is a random value. You can take any value what you want. So first we take this value that is of profit is equal to 350, and we can take any point. For example, like for a starting purpose, I must say that you must well aware of about the line equation. So if we have to use this equation like 10x plus 14y, so we have to find y. So we can find y in terms of x. So we can suppose any value of x, like if we suppose value of x is equal to 10, so we can get y is equal to 17.85. So you can see whatever value you take, your value will lie in this line. So this line I have drawn for your convenience, and for the other purpose that we will take in next graph. So this value or this graph is basically belongs to this second one. You can see 350 is equal to 10x plus 45, and you can relate it from the equation of line. You can have any value of x and y, any realistic value of x and y, so you can plot on it. Second, we will take the point 620 that belongs to 10x plus 14y. So we have a line here that belongs to red color. And the third one we have 700 is equal to 10x plus 14y. And that you can see this is the yellow line. Now, well, this lines are not necessary. You have to draw, but for the better understanding, you have to draw this. So you can have a clear idea that what you are going to do. Now you can see that this can also be done by your scale, or if you can do it by your hand. So I think this graph is clear. Now what we have to do, as we discussed in our problem statements, we have two major constraints. One constraint is 3x plus 2y, that is equal to 120. and the second one is x plus 2y, that is equal to 80. Now we can have these value again the same using equation of line, y is equal to 10 minus 3x. Now we will set this value, and again we will choose any value we can. First we will choose that x is equal to 0, the minimum value. If we choose x is equal to 0, so we have this value 120 over 6, that is basically 60, y is equal to 60. So we have x0 and y60. So we can plot here. You can see 50 and 60 on y-axis and 0 on x-axis. Now again, we will draw this by putting x is equal to 40. So by putting x is equal to 40, so we can see that we have y is equal to 0. Now why I choose these two values? Because we can get this the end point from this. So the line lie because the line lies between these 2 points, point A and point B. So we have this line for this 3x plus 2y constraint that represented in this red color. The second constraint we have is x plus 2y, that is equal to 80. So the same thing we will do here. The y is equal to 0 we have. So on y is equal to 0, that is here, and x is equal to 80, you can plot this graph. Again, if y is equal to 40, this one, you can plot this. So again, these two point comes for the second constraint we have given in the question. So again, we can see that this is the graph we have. Now the what is the important thing? We have the 2 points here, and the solution lies in the this intersection point. Now we can see that what is the intersection point, and the intersection point is 2030. So we can verify it from the graph. X is equal to 20, we have this. At this point the two lines are intersecting, and y is equal to 30. So this is the point that is of 30. So at x20 and x30, according to the graph, we are getting the maximum solution. So we have to prove it mathematically also. So this is a graphical solution we have. So for the mathematically, we have this equation earlier in our question, that is 10x plus 14y. So x value we have that 20, and the 30 value is of y. So we can get the profit, that is 200 plus 420, that is of 620. Now remember that 620 is the optimized solution we have. Now graphically we can see this is the area. You can see this is the area 20, and this area, the whole inner area, we have this in the graph, that is of the optimized solution we have. Now if we get out of this basically square, so we cannot get the optimized solution. So in decision planning, we have to manage the optimized solution, and we need the optimized solution to solve our problem efficiently, like we discussed in our question. The two major constraints we have, the cost or the product. So again, if I draw this graph here, so the red line you have of the first constraint, and this uh, black line you have is of the second constraint. Now this dotted line is basically belongs to your profit. Now you can prove graphically that this dotted line is basically your maximum profit. So this is the maximum profit you're having in this case. So I hope you will understand the numerical, and you can have any problem by this. So if you have three constraints to solve or four, so equation will change. You will have three variables for it also. So I think you understand it very well. Thank you. Bismillah Rahman Rahim. The second question we have of decision making under risk. Um, as we studied about the risk management, so risk is the important factor in decision making. So here we have this payoff table, which will have help us in deciding our um, alternatives on the basis of their probabilities. So you can see on the leftmost side you have the alternatives. So whenever we are making any decision, we have the alternative decisions. So on the right topmost first line, you have a state of nature of decision, and on the basis of a state of nature of decision, you have the state of nature of probability. So we have this O. You can see this O. So this O basically representing the outcome. So you can say this, um, any alternative have a state of nature and also its separate outcome. So if we change the alternative, we have the different outcomes. So this is the basic we have to see, and the solution in the decision making under the risk is the alternative that is represented with AI that provide the highest expected value. So the expected value, you have this formula. We have the problem here, that is, for example, consider the simple payoff information that is given in this table with only two alternative decision and two possible state of nature. Now this alternatives can be more than 1, 2, 3, and 4, and along with that the number of alternatives we have, so we have that state of nature also. Alternative A, one has a constant of $2,000, and A2 has a cost of 0.1 million or 1 lakh dollars. If future N2 take place and none otherwise, at first glance, alternative AI look like clear winner, but consider the situation when the probability P1 of the first nature is 0.99 and the probability P2 of the second state is only 0.01. The expected value of choosing alternative A2 is only A. So this is the equation. We have this, and if we see it, um other than risk management perspective, so we can say that this A2 is basically might be the winner, but I think this is not the true. So if you solve this, so we can get the answer. So um, we are solving this from this equation. The given equation is we have this 0.99, and the first alternative value we have N1 is minus 200, and the second one 0.01 is of equation, and N2 is minus 200. So at this we get the expected value of minus $200. So by putting the same in the second equation, we have this 0.99, and the N1 we have on A2 is 0, and same in the case we have N2 for A2 cases minus 1 lakh or 0.1 million. So here the expected value is minus 100. So we can see that the highest expected value is minus $100, and that belongs to E2. So here we can see that this is the A2 is the best alternative in this situation.